Hi all, let's start our discussion on linear algebra. So as discussed in the previous video, we would be talking about the intuition behind the topics, little bit of math whenever required in this series of video. If you want R or Python implementation, we can discuss that too in separate videos. So as discussed in the previous video, we will talk about the intuition behind each of the topic and little bit of math whenever required. We can talk about R or Python implementation too. If you want me to cover, we can cover that in separate videos. So let's start with the basics. When we talk about basics in linear algebra, we discuss these topics: scalars, vectors or points. We talk about vector operations, we talk about matrix operations, linear transformations, and their geometrical interpretation. So let's start our discussion with scalars and vectors. So scalar is nothing but a number. For example, I say distance is 80 kilometer. Distance from one place to another place is 80 kilometer. So 80 kilometer is a number. Kilometer is a unit and 80 is the magnitude. So distance is a scalar, right? I said time, it takes 2 hours to reach there. So 2 hours, hours can be unit and 2 is the scalar there. So these are simply the number. But what are vectors? If you are thinking about that, vectors are basically building block of linear algebra. Vectors and matrices and their operations. You need to understand these things very, very well. Even if you think that these are silly things to do and I already know these things, I would say that just you need to brush up these things before you move ahead to the advanced topics, so that you can join the dots about what theory you have learned and how these relate to when you apply it in practice, right? So vectors are basically, there are two kinds of definition. One is vectors are arrows pointing in the space with the direction and the length. And another way of thinking vectors is as a list of numbers. How really these two things are related and what do we mean by these things? Let me tell you here that vector means this can be a vector. So this is a vector because this is pointing towards this direction. It is not just a number, it has a direction also, right? So it has a magnitude, it has a direction. So we can call it a vector. And to denote a vector, we use arrow. For example, this is a vector u. So we put an arrow mark on top of it to specify that it is a vector. For a scalar, we can just use A, B, C, alpha, beta, whatever you want to write, right? Alpha, beta, gamma, A, B, C, whatever, these can be scalars, or K or Z or lambda, whatever scalars you are using in your particular area of study. But if you want to specify vectors, usually in mathematics, physics, you might have heard about, we use these kind of notations. U is a vector, V is a vector, and this arrow mark here is telling us this is a vector. Vector means it has a magnitude. Magnitude means length of the vector, and direction means in which direction it is pointing out, right? So this is a vector. Now, those who are from physics, they might have done this kind of a thing, that if this is a vector, so direction we can measure by this angle, means the direction, this angle between the vector and the x-axis. So whatever angle it is, right? So if we know the angle, if we know the magnitude of this vector, we can identify what the vector is. Now in physics, if we move this vector anywhere else in the space, this is a two-dimensional space. If I move the vector here as well, and if I keep the angle same, it is the theta angle again here. If I just roughly draw it here, it is theta. And if the length is also same, I can say that these two are same vectors. So these two are same vector. I can give it separate name or I can give it the same name, because if it has the same magnitude, same direction, these two are the same thing. This kind of stuff physics student do, right? But usually when we do linear algebra, we start our vector with the origin. I hope you all are familiar with what is origin. Origins means 0, 0 point. I hope you all understand this kind of a graph. We call it Cartesian plane. In a graph paper, you might have seen these kind of lines. Here it is called x-axis and here it is called y-axis. And the intersection of these two is the origin point. We denote it by O and it has coordinates 0 and 0. So this was math you might have done in your high school. So in linear algebra, almost always we start the vector at the center. Fine. We can also denote the vector in form of a point. How we can do that is, for example, this is the vector u. Now I have not made any marking here, but suppose this is my x-axis, so it is 1, suppose it is 2 and it is 3 here. And similarly, suppose it is 1, 2 and 2.5 here. Then the coordinate of this point would be, I hope you might have guessed, 1, 2, 3. So x coordinate is 3 and y coordinate is, it is 1, it is 2, it is 2.5, so 2.5. So this is the coordinate of this point, the tip of the vector, right? So instead of drawing a vector like this, we can also simply make a point and we can denote that point with this coordinate. For example, this is the xy axis and I have some point here. Now, whenever we have a point, we can always decide its coordinates by looking at where it lands on the x-axis and where it lands on the y-axis. So suppose the coordinate of these points are 4 and 4. We can also understand this point as a vector because in linear algebra, we start the vector with 0, 0. This would be the direction of this vector and here it would be landing. So we can find out the length of this vector, we can find out the direction and we can say this is the vector. So there are two ways of defining a vector. Either you can define it by using the arrow, and in linear algebra you start the arrow from origin most of the time, or you can define it by using a point in the two-dimensional or three-dimensional plane. You can have multi-dimensional also, but for the sake of simplicity, so that we can visualize, I am drawing it in the two-dimensional plane so that you can understand. I hope you have done this much of geometry in your high school so that you can understand Cartesian plane and you can understand the coordinates, how we find out the coordinate, right? So this is how we can define vectors geometrically. If you want to visualize it, we can use arrow or we can use point. If it is a single vector, it would be recommended to use arrow so that we can visualize where it is and how it is related. So if you are a computer science student, you might have used arrays or list of numbers where you have some numbers like 4 and 3. It is a list of numbers or array of numbers depending upon what language you are using. In Python, you call it list, or if you are creating NumPy array, this can be array also. So this can also represent a vector because we take this as the x coordinate, we take the second element of that list as the y coordinate, and we can create a vector whose coordinates are 4 and 3, right? You might have seen vectors like this 4, 3, minus 7. So this is again a vector, but this vector is in 3 dimensions. In 3 dimensions, this is your x coordinate, this is your y coordinate, and this is your z coordinate. So accordingly, you can define the vector as the list or array of the element. In your programming language, you usually use these kind of structures to define vectors. So for physics student, this kind of interpretation is better to, this kind of interpretation is more clear for them to understand. For computer science student, they prefer to use as a list or array. If you are from mathematics, you prefer symbols also. So suppose u is your vector. As I said, you need to denote it by using arrow mark here. And as I said, each vector can be represented as a point in the Cartesian plane. So if you are representing it as a point, it would be having x coordinate, it would be having y coordinate. So you can write the x and y coordinate of this vector as ux, this is the x coordinate, and uy, this is the y coordinate. So these are just the coordinate, and we will talk about it. Mathematics students write it little more complicatedly, right? Ux I cap plus uy j cap, where I cap and j cap are unit vectors. We will talk about it if you love math, otherwise you can skip this detail. I hope this thing is clear. Now, so this is your x-axis again, this line, and the vertical line is your y-axis. Again, we are talking about two-dimensional space only. These markers are representing 1, 2, 3, these units, right? So if you talk about 1 unit on x-axis and 1 unit on y-axis, this would be basically your unit vector in the direction of those axes. So if I make a vector here, this is having 1 unit only and the direction is on the x-axis. So it has a special name. We call it I hat. right? This is a vector, we call it unit vector in the direction of x-axis. And similarly, unit vector here in the direction of y-axis, it has a special name j hat. So if you have any vector here, this vector has the coordinate 3 and 3. So this vector is basically, what you are doing is you are starting from here, and vector means moving in that direction. So 3 means in the direction of x-axis you are moving 3 steps. So 1 step, 2 steps, 3 steps, you are here. The coordinate of this point would be 3 on x-axis, and there is no y component, y0. You are here, but you want to reach here, so you will move up. And how many steps you will move? 1 step, 2 steps, 3 steps. So the coordinate becomes here 3. So the vector which I have created here, 3, 3 vector, can also be written as what we are talking about, taking 3 steps here. This is 3 steps in the direction of I hat, and this is again 3 steps in the direction of j hat. So we can also write this vector u as 3I hat plus 3j hat, right? So if you are a beginner and you struggle to understand these things, you can practice it with creating few more vectors yourself and see. Suppose I have created this vector and this has coordinate 5 and 2. So you can create those steps and you can visualize it can be written as 5I cap plus 2j cap, right? So these are different ways of writing a vector in two-dimensional space. What about if you have three-dimensional space? So in case of three-dimensional space, drawing it on a screen or a sheet would be difficult. Either you need to use some animations, but let me show you. So suppose this is your two-dimensional space. This is a plane, your two-dimensional space, and this is your x-axis, this is your y-axis. And you were creating a point there and you were finding out the coordinate. So suppose you were having a point here, or you can say arrow here. So you were finding out the x coordinate and y coordinate to represent it in the form of a point. Now, for example, if you have a three-dimension vector, so 3 dimensions means something like this. If it is not visible very clearly in this screen sharing option, you can see it is like this. 3 axes all perpendicular to each other. If you can't visualize it correctly, you can look at the ceiling of your room. It always have the 3 axes perpendicular to each other. When I was student, I used to look at the ceiling so that I could visualize it. Now, if you have a point or say an arrow in this three-dimensional space, so I hope you can see this. So suppose this is the point here in the three-dimensional space. Now you need to find out the coordinate of tip of this arrow, this yellow arrow, on these 3 axes. Now it can be x-axis, y-axis, z-axis, or whatever way you have defined it, right? So you need to find out coordinates in those axes. And very similar manner as you have done in two-dimensional, you can represent a vector in three-dimensional space. So in case of 3 dimensions, your vector would look like ux I cap plus uy j cap plus uz k cap. Or if you are using a list or array to represent a vector, you would be representing it as, for example, 10, minus 5, and 2, whatever you have. So this is again a vector. You can write it in the form of a column as well. For example, 4, 3, minus 2, like this. So I hope you got an idea about what the vector is. Now let's talk about some of the popular vector operations. Vector addition and vector multiplications are really very important. We will also talk about vector subtraction and dot product, cross product, etc. These are important concepts so that you can understand little more in linear algebra. So let's first talk about vector addition. So basically vector addition, how does that work is you want to add up 2 vectors. For example, this is one vector and this is one vector, and suppose it has the coordinate of 3, 1. And for example, this is another vector which has the coordinate of 2, 2. So this can be one vector, this can be another vector, u and v. I have given them name. Now, if you want to add these two vectors, there are different ways you can add, right? Geometrically, if you want to add, how this happens is you basically shift one of the vector on top of another vector. For example, if you want to perform u plus v, you can shift v, this v here, so that v starts from here, and the length of this vector in the direction remains same. You just create a copy of this vector. You just shift this vector. If you can imagine that this is your u, this is your v, and you are just shifting v here so that it goes to the tip of the vector u, right? And if you are able to do this, you can find out this new vector, which is given by this orange color, and would be representing the sum of these vectors. Let me show you here in the graph that, for example, if you shift the vector v here as it is, I might not be able to draw it very perfectly, but still it will give you some idea that parallelly I'm trying to shift it, same length, same direction. Suppose this is the v vector, which I have just shifted for the purpose of understanding the vector addition, right? Because we know that if the length and directions are same, it is the same vector, right? Then basically this is u, this is v. I want to add up these two. So geometrically, the sum of these two vector would be, let me show you by using a different color. It would be like this vector, which is starting from origin and reaching up at this top, right? So let me draw the vector here. This would be u plus v, the new vector, right? And if we talk about the coordinate of this vector, how we know what would be this point and how we know the coordinate of this vector is basically what we have done when we have created this sum of the vector is we wanted to add u and v. So basically this u is 3 and 1. And what does this 3 and 1 mean? If you remember from the previous discussion, this 3 is in 3 step in the direction of x-axis. So 3 step here, then 1 step in the direction of y-axis, so 1 step here. Now what does this v vector do? It takes 2 more step in the direction of x-axis, so again 2 step here, and it takes 2 direction up in the direction of y-axis, so again 2 step here. So if we find out the coordinate, the x coordinate would be 3 plus this 2 horizontal distances, so this would be 3 plus 2, and y coordinate would be the sum of vertical distances, which is 1 plus 2, so it is basically 5 plus 3. So what 5 comma 3, so this would be the sum of these two vectors. So basically what we are doing is we are adding up the x coordinate and we are adding up the y coordinate, or we can write it mathematically as this is my x coordinate ux plus vx, this is my y coordinate uy plus vy, if we want to write it mathematically. But if you are finding it too heavy to understand vector addition like this, where you can't even move the vectors and you can't see why this is happening, let me show you by using a web applet. So you see here this diagram above, this point is origin, these are the vectors u and v which you want to add. In this web applets, you can use this slider to choose different vector operations and see how these are working. If you want to look these things in 3 dimensions, you can show 3 vectors here, but I'm just showing it to you in 2 dimensions. So here u is 3 and 0 because this is 0, 0 point, 1 step, 2 step, 3 step in the direction of x-axis. So 3, 0 is the coordinate. For v, 1 and 2. So x coordinate is 2, y coordinate is 1 and 2. I hope this is clear. If you want, you can change the coordinate. For example, the example which we have discussed, we have taken u equal to 3, 1. So let me move it 1 step up. This is u equal to 3, 1 now. And we have taken v equal to 2, 2, I think. Yeah, so v equal to 2, 2 is here. If you want, you can just rotate it and change whatever direction you want to do. But we were doing v equal to 2, 2. Now, if you do this, represent the sum of these vectors. Basically, you shift the v here and the diagonal, or you can say the line which joins U and V. You can see here it is becoming more clear in the second picture that you have shifted V from here to here, and then you are joining from the origin to the tip of this vector, and that would be your sum of these vectors. So this is how geometrically you can play around, and you can see even when the directions are in opposite direction, how does that work, and how you can compute the sum and all those things. So you can go ahead and always check what should be the sum. And one more benefit of using this tool is you can verify your answer. So mathematically speaking, if you want to find the sum of these two things, the x coordinate would be 3 plus 2, which is 5. So let me enter 5 here, and y coordinate would be 0 plus 2 would be 2. So you can see the correct answer is there. So if you are absolute beginner, you are finding even these concepts heavy, you can use these kind of web applets to do your practice. If you don't like doing it on paper and pen where you can't really move things up. Now comes vector subtraction. Now I'm not doing vector subtraction right here, but it is very simple and similar concept. Vector sum means you want to do, this is your u, and you want to subtract some vector v. So basically it is exactly equal to doing u plus minus of v, and minus of v means the same vector but in the opposite direction. If the coordinates are 3 and 5, you will make it minus 3 and minus 5, and again you will shift and you will do the computation. So if you want to do it graphically, you can do it. If you want to do it mathematically, you can do it too. So mathematically, the result would be ux minus vx, subtracting the x coordinate and subtracting the y coordinate. This would give you the vector subtraction. So I leave it for you to explore. Otherwise, you can do the same thing in the web applet also, which I have shown you. Now let's talk about scalar multiplication. Wait, what is a scalar? I told you a scalar is a number, right? It is a real number by which the vector stretch or shrink when we multiply it with that scalar. How do we understand scalar multiplication? So again, suppose this is your x and y axis, and suppose this is your vector 3, 1. So suppose this is your x coordinate, which is 3, and y coordinate is just 1. And this vector is having a name u. Now, if you want to multiply it by 2, so 2u would be nothing but the same vector double in length, same direction, but it should be. So instead of 3 here, it would be having up to 6 here. So you will just stretch this vector to go up to 6 here, and this would be your 2u vector. The new vector which you have created, it would be your 2u vector. If you want to do it 5 times, you can stretch it all the way up to 5 times the length of original u. If you want to do it minus u by 2, minus means you will go in the reverse direction, and by 2 means you will just half its length. So it would be 1.5 here in the reverse direction. So this is the way you can compute a scalar multiplication. And if you want to visualize it, you can again go back to the applet and explore. So this is the original vector. Here is the origin, and the vector coordinates are 2 and 2. I hope you can understand. This is 1 and 2 block on the x-axis, 2 block on the y-axis. Now, if you want to do scalar multiplication, here is where you can define the scalar. You can even drag the scalar like this, or you can just give the value here. For example, I just want to do it 3 times. So the green line here is 3 times the original vector, right? And if you do it, this is the original vector, and it is now decreasing direction. It is 0 because you have multiplied the vector by scalar 0. So it is the vector 0 vector, and it is in the negative direction. So it is just flipping the vector, and you can even do it in the negative direction 2 times, 3 times, whatever, right? So this is how the scalar multiplication works when you look at it geometrically, and definitely you can enter your answer there and see what happens. So in this tutorial, we have just talked about very low level introduction of vectors and the basic vector operations. We will talk about the dot product, cross product, length of the vector, these kind of operations, transformation, basis, span, all these things in the upcoming video. Stay tuned. Thank you for watching.